over the past few lessons, we have learned two different types of reactions, right? The first reaction is what we call a dehydration synthesis. It is basically the removal of water. To make something. So one example would be having a glucose molecule, put it next to another glucose, remove a water molecules between the two glucose molecules. So now they form a covalent bond. We just created a new molecule from two separate molecules. This is a glucose, and then we connect them together through this covalent bond by removing a water molecule. So we just make a maltose. Two glucose becomes a maltose. So this is dehydration synthesis. A second reaction is what we call a hydrolysis. We're going to take water, hydro means water, and lysis means breaking down. It is actually a reverse of dehydration synthesis if you think about it. We take a maltose molecule, which is two glucose molecules covalently bonded. If you wanted to know the scientific name for that covalent bond, it's what we call a glycosidic bond. And we're going to take one water molecule, and attack that glycosidic bond or covalent bond and break it apart. Water molecule is going to reattach back. A maltose is going to be broken down into two separate glucose molecules. So two separate glucose molecules here. This is hydrolysis. So reaction 1, reaction 2. And as you realize, these two reactions happens very frequently in our body. We constantly eat things. Through digestion, we break down very complex molecules into simple molecules so that our body can use it for different purposes. However, these reactions is very difficult to proceed in our body. It's very difficult. Not that it cannot be done, but the reaction rate is very slow. It takes forever to do this in our body. So we have this special protein. A protein that can speed up this reaction in our body, and we call this protein an enzyme. So what does an enzyme do then, right? So enzyme, we know that it is a protein. It is a special protein. It has 3D shape because of the unique properties of proteins. Those long polypeptides can get folded, coiled together, entangled. And what you realize that is when I entangle that long string of polypeptide, it will create this unique active sites, right? Those shapes that can fit those reactants into the 3D shapes. So now what is a reactant? In a reaction, what happens before the reactions? The material that we have before undergoing some changes, we call those stuff the reactants. And once we have those reactants undergo some sort of reaction, we call those things products. And when you have a reactions going on, you're going to need those reactants to overcome some sort of energy barrier. So energy barrier. It is a requirement of energy for the reactants to overcome. So you can imagine it like a hill. These are reactants, you know, like your glucose, sucrose, maltose, right? Those reactants that needs to undergo some sort of reactions so that they can either be synthesized or broke down. So those reactants need to overcome this energy barrier. So this is the energy barriers that they need to overcome so that they will become products. Maybe they will get broken down into glucose, or they can become a new polymer. So where is the energy barrier? So this is the energy barrier, right? This particular height here, from this point all the way to this point is the energy barrier. So one example could be a picture like this. This is the activation energy barrier, right? A barrier that prevents all these frogs here to jump over. They want to become products. So before they undergo this reaction, so right here, this is the reaction, they can change the reactants to products. And this activation energy barrier is blocking them from becoming the products. What enzyme does is that it's going to lower this activation energy. This energy barrier is going to make it lower. or take it away, make it even lower. So maybe somewhere like here, right? So when you have an enzyme, this energy barrier suddenly becomes lower as compared to this one, right? So this is without enzyme and this is with enzyme. Enzyme comes in, the energy barrier is lower, so what you can see is that more frogs can jump over to become products. So that is the role of enzyme. So how does enzyme achieve such a significant feature, right? We know that without enzyme, all these reactions that is needed for our body to do work will not be able to happen. It's very difficult in our body. So protein has all these active sites, right? It's a protein, so it has those unique shapes like a hole to bind to the reactants. So when we say that the enzyme can bind to the reactant, those reactants that need to undergo some sort of reactions to become a product. So this is the product. The things that's going to bind to the enzyme, we call it substrate. So now I'm going to draw a 2D shape of an enzyme, right? A 2D shape for an enzyme. So here I'm drawing a simplified version of an enzyme, right? Enzyme. And the hole here represents the active site. If you remember, the enzyme is a protein, and protein has a 3D shape, and these 3D shapes can create some sort of holes for the reactants to bind towards it, right? When a reactant can bind to the enzyme, we call that reactant a substrate. So now I'm going to draw a substrate, maybe a maltose, which is a disaccharide, a maltose, 2 glucose bonded together. So this maltose is going to bind to the active sites of that enzyme. We're going to bind to the active site of the enzyme, and it fits, right? Kind of fits, draws without according to the proportion. So substrate is some reactants that needs to undergo some sort of reaction that can bind to the active site of the enzyme. And if you remember, the role of the enzyme is to speed up the reactions by lowering the activation energy. Enzyme will lower the activation energy, which is the barrier that can block reactants from becoming products. When it spits out, now it's easier for the substrate to become the product, which is glucose. So this enzyme is specialized in doing hydrolysis, which is the breaking down of complex molecule into simpler molecule. So the bond is broken. So what happens is that you're going to end up with having 2 glucose molecules, and they will leave the enzymes, right? So these glucose molecules will just leave the enzymes, and the enzyme stays intact, so we do not destroy the enzyme. So this enzyme can be reused again. For the next reaction,